The notes from yesterday are up on the board. So here, guys, for velocity time graph, we have a couple different points here labeled. We're going to call this line segment 1, 2, 3, 4, and 5. So to find distance, you can use the equation of initial velocity plus final velocity divided by 2, and then multiply it by the time. Or you can do area under the curve. So if it's a triangle, okay, you go up to 60, and you would go up, the line segment ends at 0.2. So I could literally do 60 times 0.2 and then divide it by 2, because that's what you need to do for a triangle. For a rectangle, you could just do base times height. So height 60 and the width here 0.2, 60 times 0.2. But I'm just going to show it using this equation here that was given. So for 1, initial velocity is 0. Final velocity at the end of point A is 60. Divide that by 2. And then times it by the time, which was 0.2. And that is going to come out and give us 6 kilometers. For line segment 2. All right, so for 2, same kind of idea. Initial velocity at the start of this is 60. The final velocity at this is 60. Divide that by 2. And how long were you moving for? All right, so it starts here at 0.2 hours, and then it goes to 0.4. So the time is, all right, 0.2 again. Okay, multiplying this John out, you're going to kick out 12 kilometers. Line segment 3. Your initial is 60. Your final here is 0. Cut that in half because it's a triangle slope. Great. And multiply it by how long we were moving for. So the start of this was at 0.4 and it ends at 0.7. So you're going to multiply this one by 0.3 hours of your time. And you're going to kick out 9 kilometers. C and D. Well, velocity is 0. So again, you should just realize that there is not going to be any motion there because it's not moving. But just throwing it into here, 0 plus 0, 0 divided by 2, still going to be 0. Times something, you're only moving for 0.1 hours. It's going to give us 0. Line segment 5. Oops, I didn't even see. There's 6 right there. 5. Initial is 0. It gets up to right here, which is 40. And it goes from 0.8 to 1, so that's 0.2. So 40 and timesing it by the time of 0.2. You're going to get 4 kilometers. And then the last one, line segment 6. Initial is 40. Final is 40. And multiply that by the time that it was moving. So from for 1, to 1.1, it would be 0.1, and that is also going to give us 4 kilometers. So this is how much distance we have traveled. All right. Now, we can this should help us figure out, all right, some of this stuff here. All right, so how much distance was covered from point 0 to point A? So line segment 1, 6 kilometers. Did the work for that already. What time interval had the greatest velocity? So essentially, that should be easily be able to be told from, all right, the slope itself. Whichever one had the steepest slope. So I'll tell you right now, obviously it can't be any of the flat lines. Well, actually, I apologize. So because this is a velocity time graph, slope is going to refer to, all right, acceleration. So there's acceleration here. It's going towards 0, so it's slowing down, not moving, speeding up, and then moving at a constant velocity here. So point A and B are where you have the greatest velocity, because at those points, you're at 60 kilometers per hour. So I guess we could technically say from point 2 to 0.4 hours, or A to B. But if it was like on a quiz, A to B might not just be an option. It would be like, because if they're asking for specifically time interval, so 0.2 to 0.4 hours. What was the greatest velocity? Oh, well, we already kind of just said that. 60, and the unit, not meters per second on this one, it is kilometers per hour. How much distance was covered in total? Well, good thing we did all this, so now we can just add them up. So 6 plus 12 plus 9, 27, plus 8, 35. Sounds right. So if we add all the distances, okay, we're going to get a total distance of 35 kilometers. Okay, how fast was the car going at 1 hour? Yep, so you're going to just go to time, not 0.1, but 1 hour. Go up until you hit your slope, and then go across, so 40 kilometers per hour would be your answer there. Okay, what is the acceleration from D to E? So for line segment 5. So for line segment 5, it is going to be final velocity minus the initial velocity divided by our time interval. Okay, so what is our final velocity during this line segment? Okay, so VF 40, VI would be at the start of 0, and how long were we moving for? From 0.8 to 1, which is 0.2 hours. All right, so the equation that's given over here on the left, you're just going to plug in your numbers. VF minus VI over 0.2. And the acceleration, therefore, will come out to give us 200. No. Well, let me see. 40 divided by 0.2. Yeah, no. Okay. Yeah, 200. And now the unit is going to be whatever your speed unit is, speed or velocity unit, divided by, or usually divided by the time unit. So this one will be, most guys, majority of the time, it will be meters per second squared. But in this case, it's going to be kilometers per hour squared. So this, all right, so again, to find the acceleration for this line segment, the equation was final velocity minus the initial velocity divided by how long it was moving. At this point, go across, you're at 40. Here you're at 0, and you're moving for a time of 0.2 hours. 40 minus 0 divided by 0.2 is going to give us 200, and the unit for this, in this case, is going to be kilometers per hour. Majority of the time, though, it will be in meters per second squared. Okay. All right, and now you're going to plot. We have two cars here, so you're going to plot those positions. So you can start with car A and draw in, all right, all the information that it's going to tell us. So for car A, at 0 time, we're at 0. At 2, we're at 2. At 4, we're at 4. At 6, we are at 6. And at 8, we are at 8. Car B. Now, it's already starting at 2 kilometers. So I'll make this one like a little triangle. At 2, we are at 3.5. So 2.5, 3. Oh. So it looks like 0.4, 0.8, 1.2, 1.6. So everything's going up by 0.4s. All right, so that would put 3.5 right around here. Oh, sorry, I said triangles. At 4, we're at 5, which will be somewhere right around here, right in the middle of those two. 6, we're at 6.5. So just above that little line there. And then 8, we're at 8. All right, so my triangles. Cool. And then car A. That's car A. This line, or this slope, is car B. All right. So plot those and then use your slope equation to find the velocity. So you can pick technically any 2 points. So velocity at car A. Yep. Sorry. So for this, final position minus initial position. So I could literally do 8. No, that's probably not the best idea, actually. No, I could do that. Okay. So I could do my final position minus the initial position for A. So final position would be at 8 kilometers. Initial would be at 0. And the time frame would be 8 minutes. So you can use this equation, but 8 minutes would be on the bottom. So we're going to have 1 kilometer per minute. And velocity of car B and so for the velocity of car B, we could have final position of 8 minus my initial position of 2. And that whole time frame would be from 0 to 8 minutes. So 6 over 8 would be just 0.75. And it should make sense because slope A is steeper than slope B. Basically, it'd be like if you were racing a younger sibling and you are line A and they're line B, you give them like this is kilometer. So maybe on a bicycle. No, that would suck. Car. No, because then everyone could drive safe. Okay, we'll just say it's a race, okay? But essentially it's the idea. You're giving them a head start because they're not going to be as fast as you. All right? And then you guys would eventually tie right there at the end. Okay. So that is that. Now, on this backside, what you guys are going to do is you're going to solve for, all right, the acceleration from each of your line segments here. You have the equations for you. So initial plus final over 2 times the time to find the distances, all right, traveled from each of these. And then to find the acceleration, you're just going to do final minus initial velocities. That's what the VF and VI stand for. And then just divide it by the time interval. All right, so let's work on this, and then you guys will get your homework assignment, which is you'll have plenty of time to start it, and it's something very similar to this, where you're going to have to find the accelerations, distances, and the total distances traveled. Mm-hmm.